In this episode, we are focusing on one of the most important design habits in responsible artificial intelligence, AI, work, spotting risk early enough that the team can still do something intelligent about it. Many beginners assume that risk becomes visible only after a system is launched and starts making mistakes in front of real users, but strong governance tries to identify design risk before the system reaches that point. The goal is not to predict every possible problem with perfect accuracy, because no team can do that. The goal is to surface likely harms, understand who could be affected, decide which risks deserve the most attention, and choose mitigations that change the design while change is still possible. That is where harms matrices, risk hierarchies, and stakeholder mapping become so useful. They give teams a practical way to move from vague worry into structured thinking, so the design can become safer, clearer, and easier to govern before momentum and deadlines make thoughtful revision much harder. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A design risk is not just a bug waiting to happen. It is any feature, assumption, workflow choice, data dependency, or system behavior that could create harm once the AI system is used in the real world. Sometimes the risk comes from the model itself, such as unstable outputs or poor performance on certain kinds of inputs. Just as often, the risk comes from the surrounding design, including what the system is allowed to do, how its output is presented, how much authority people give it, what data it relies on, or what kinds of users are expected to interpret it correctly under pressure. This matters because teams often focus on technical quality while ignoring the fact that a design can encourage over-reliance, hide uncertainty, normalize weak reasoning, or affect people very differently, depending on their role and circumstances. When you hear the phrase identify design risks, think less about dramatic failure and more about the quieter ways a system can steer behavior, shape decisions, or create unfair burden through ordinary daily use. One of the most useful tools for making those risks visible is the harms matrix. A harms matrix is a structured way of laying out possible negative outcomes so the team can compare them instead of discussing them one at a time in an unorganized conversation. It usually helps the team consider several dimensions at once, such as who could be harmed, what kind of harm could occur, how serious that harm might be, how likely it is to happen, and whether the harm would be easy or difficult to notice and reverse. The reason this tool matters is simple. Once a team writes possible harms down in a visible pattern, hidden assumptions start to surface. A system that seemed harmless when described in broad terms may look very different when the team sees side by side that it could create privacy loss, unfair exclusion, reputational damage, workflow delay, safety concerns, or a gradual loss of meaningful human judgment. The matrix does not think for the team, but it forces the team to think more clearly than casual discussion usually allows. A good harms matrix begins with categories that make sense for the use case rather than with generic labels copied from a template. In one setting, the most important harms may involve fairness, privacy, or access to opportunity. In another, the deeper risk may involve misinformation, missed escalation, safety impact, emotional distress, or the erosion of trust in a process people depend on. The team should ask what kinds of people or groups could be affected, what the system might do wrong, how the error or misuse could happen, and what the real-world consequence would look like if the problem occurred repeatedly or at scale. It is also useful to distinguish between direct harm and indirect harm. A direct harm may be a bad recommendation, a missed urgent case, or exposure of sensitive information, while an indirect harm may appear when staff begin to trust the system too much, rely less on their own judgment, or build new routines around a tool whose weaknesses are still poorly understood. The matrix becomes more valuable when it captures both visible and less visible forms of harm rather than focusing only on the most dramatic outcome. This is also where teams benefit from looking at harms as more than one kind of problem. A system can cause immediate harm to an individual, but it can also create group-level or organizational harm that is slower and harder to detect. An AI tool used in hiring, education, healthcare support, or workplace review may not create spectacular failure on day one, yet it can gradually reshape who gets attention, whose cases move faster, whose records are treated as more trustworthy, or whose language style is interpreted as more urgent or more credible. A harms matrix encourages teams to widen the lens and ask whether the design changes incentives, changes behavior, or produces hidden trade-offs that the project team would otherwise miss. That wider lens is especially important for beginners because people often think of harm as something obvious and immediate. In reality, some of the most important design risks are cumulative. They emerge through repetition, through routine use, and through the slow normalization of outputs that appear efficient but quietly make the system less fair, less careful, or less accountable over time. Once harms are visible, the next challenge is deciding how to respond to them, and that is where risk hierarchies become useful. A risk hierarchy is a way of prioritizing mitigation choices so that the team does not jump immediately to the weakest control simply because it is convenient. In plain language, the hierarchy asks whether the team can remove a risk, narrow the use case, redesign the workflow, or limit the system's influence before it settles for softer measures such as warnings, instructions, or after-the-fact review. This matters because organizations often choose the least disruptive mitigation first. They add a note to the interface, ask users to be careful, or promise extra training, while leaving the risky design choice in place. A hierarchy pushes the team to ask a harder question. What is the strongest practical way to reduce this harm at the source? That mindset usually leads to better governance because design-level changes are often more reliable than reminders that depend on busy people behaving perfectly under pressure. A useful way to understand risk hierarchies is to imagine them as a ladder of design discipline. At the strongest end, the team decides not to pursue a risky feature or excludes a category of use that it cannot govern safely. Just below that, the team may simplify the task, reduce the system's autonomy, restrict who can use it, or require a stronger review step before sensitive outputs can influence action. Below that level, the team may rely on thresholds, escalation paths, logging, monitoring, or interface choices that slow people down when uncertainty is high. The weakest end of the hierarchy tends to include general warnings, broad policy language, or training alone without any supporting design change. Those softer measures are not useless, but they are rarely enough on their own when the use case has real stakes. This is why risk hierarchies matter so much in AI design. They remind the team that the best mitigation is often the one that changes what the system can do or how the workflow behaves, rather than one that simply asks people to remember the right thing later. Stakeholder mapping adds another critical layer because a team cannot assess risk well if it does not know whose interests are in play. Stakeholder mapping is the process of identifying the people, groups, and institutions that interact with the system, depend on its output, are represented in its data, or may experience its consequences even if they never see the system directly. This includes obvious actors such as users, reviewers, managers, and project sponsors, but it also includes less visible groups such as applicants, students, customers, patients, workers, or community members whose opportunities and treatment may be shaped by the design. A system can look well designed from the point of view of the project team while still placing hidden burden on people outside that team. Stakeholder mapping helps prevent that narrow view. It reminds designers that convenience for operators is not the same thing as fairness for affected individuals, and that a system can create value for one group while creating confusion, exclusion, or extra risk for another. The best stakeholder maps go beyond a simple list of names or roles. They try to understand how each stakeholder relates to the system, what power they have over it, what vulnerability they may have to it, and what kind of knowledge they bring that others may not. Some stakeholders have direct control, such as administrators or managers who can change settings or approve deployment. Others have operational knowledge, such as frontline staff who understand the workflow better than anyone else and can often predict where design assumptions will fail. Others are affected parties with little control, which means their interests are easy to overlook unless the team makes a deliberate effort to include them in the conversation. This is one reason stakeholder mapping is a governance tool rather than just a planning exercise. It shows where voice, power, exposure, and accountability are unevenly distributed. Once the team sees those patterns more clearly, It becomes much harder to pretend that the design serves everyone equally or that one perspective is enough to judge whether the system is safe and appropriate. Harms matrices and stakeholder mapping become even more powerful when they are used together. A harm that seems modest in the abstract may look much more serious once the team connects it to a stakeholder group with limited ability to notice, challenge, or recover from the impact. A design choice that feels efficient for supervisors may look far riskier when viewed from the position of people whose cases are being sorted, scored, flagged, or delayed by the system. This combined approach helps the team move away from generic statements such as the system may be biased or the system may be misused and toward more concrete reasoning. It encourages questions like which users are most likely to misunderstand this output, which affected people are least able to appeal a bad result, which groups are underrepresented in the data, or which stakeholders may carry the burden of error without even knowing an AI tool played a role. Once those questions are asked clearly, design mitigation becomes much more targeted and much more credible. At that point, the team can use the harms matrix, the risk hierarchy, and the stakeholder map to drive real design changes. It may decide to narrow the use case, remove a risky feature, require human review for certain categories of output, change how confidence and uncertainty are shown, limit the system to advisory rather than decisive use, or separate high-stakes cases from routine ones instead of forcing every input through the same path. It may also decide to collect different data, reject weak proxies, create a better feedback loop, or add logging that makes later review more meaningful. The key lesson is that these tools are not there to produce paperwork. They are there to improve the design before the design becomes difficult to change. If a team completes a harms matrix, talks about hierarchy, maps stakeholders, and then changes nothing, the exercise may have created awareness, but it has not yet created governance. Governance becomes real when the findings shape architecture, process, controls, and deployment decisions in ways that can be explained and maintained. These tools also help teams avoid several very common mistakes. One mistake is treating every risk as if it deserves the same kind of mitigation, when in reality some risks should be removed at the design level while others can be monitored or managed through narrower controls. Another mistake is focusing only on the easiest stakeholder to hear, usually the internal user or sponsor, while neglecting people whose exposure is high and whose voice is low. A third mistake is assuming that a warning, a disclaimer, or a brief training session is enough to handle a design weakness that really should have been addressed by limiting scope or adding stronger review points. A fourth mistake is treating harm as a single event rather than a pattern that may develop over time. When teams use harms matrices, risk hierarchies, and stakeholder mapping well, they become less likely to confuse awareness with mitigation. They learn to distinguish between noticing a problem, ranking its seriousness, and actually changing the system so the problem is less likely to occur. A simple example makes this easier to hear. Imagine a college planning to use an AI system to help sort incoming student support messages by urgency. A harms matrix might reveal risks such as missing students in crisis, misreading cultural or language differences, exposing sensitive information, overwhelming staff with false alarms, or causing advisors to trust the system too much in emotionally complex situations. A stakeholder map would show not only advisors and administrators, but also students in distress, students with disabilities, students who communicate differently, technical staff, and leaders responsible for duty of care. A risk hierarchy might then push the school to avoid full automation, require human review for sensitive categories, narrow the system to an advisory role, and route uncertain cases into manual handling rather than relying mostly on warnings telling staff to be careful. That is the deeper point of this episode. The tools do not replace judgment. They structure judgment so that design risk can be identified earlier, discussed more clearly, and mitigated with stronger choices than organizations usually make when they are rushing toward deployment. By the end of this topic, the central lesson should be clear. Teams cannot mitigate design risk well if they think about harm casually, prioritize convenience over stronger controls, or define stakeholders too narrowly. Harms matrices make possible consequences visible and comparable. Risk hierarchies push teams towards stronger, more design-centered mitigations rather than weak reminders and vague caution. Stakeholder mapping exposes whose needs, vulnerabilities, and perspectives must shape the system if it is going to be governed responsibly. Used together, these tools help organizations identify the risks that matter most, decide which mitigations are strongest, and make design changes before the system gains too much momentum to question. That is why they matter so much in AI governance. They turn vague concern into structured analysis, and structured analysis into design choices that make the system safer, fairer, and easier to supervise in the real world.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.